As I mentioned, Alejandro has been on the show before some months ago, and I'm happy to have him back, and this time to talk on a little bit different topic, direct query in Power BI. And I think I will just hand over the floor to you. And then, as always, I will be off camera, but online in the chat. So any questions that you may have, you can just ping me in the chat or to ask them in the chat. And if I can't answer them, I will sum them up and we will take a break maybe during the session or at the end to answer the questions that are outstanding. Other than that, please, allow me to introduce the next speaker, Alejandro. Welcome.
Thank you. Thank you, Jens. Thank you so much. It's really nice to be back. Can I share my screen? Can I switch to my screen?
Sure.
Cool. It's really nice to be back at the Danish community. It's a really vibrant community, I guess one of the biggest in Europe, probably, by the number of events and people that follow the community. Why is it not working, my presentation? So today, I want to share this presentation about direct query. Most of the content in this presentation is real-life experience that I had in an actual project that I found myself managing, assisting in, to migrate from an import mode situation to a direct query situation for one of my customers. And we learned a lot of lessons in the process. So the idea of today's presentation is not just to do a list of technical things that you need to consider, because as I will explain later, the technical considerations are, I want to say, quite easy to find out. You just read a book, go on the Microsoft documentation. There is a big list of technical information that you can find on direct query versus import mode versus direct lake versus whatever you want. What I want to show today is a lot of considerations. Well, there's also going to be technical considerations, of course, but I think the best part of this presentation, in my opinion, is the considerations that are not so easy to find out when you decide to switch to direct query. So let me first, let's see if I can make this presentation work in full screen, maybe. Yeah, this is my first time using this tool, by the way. It's called Gamma. I think it's really great. I use it together with Claude because I had all my material uploaded on Claude, and then I asked it to build a presentation. It was quite good. You need to tweak it, of course, like everything with AI, but it was really good. So myself, I'm Alessandro, as Ian said. I'm a freelance BI consultant and developer. I'm from Italy. I live in Bologna. I've been doing this for a few years, ever since I finished university. Pretty much I started working immediately in the BI field with Power BI, by the way. Actually, I started with Power BI before I started university. And one of my professors that teach me Power BI was Francesco Bergamaschi, who you probably know because he's a speaker at several events. So that's kind of a nice story that I started there, and now we are working together still sometimes. I'm also a community leader for the Italian Power BI user group. We organize, together with my colleagues, we organize events. The Ticino conference is our biggest event. We always do it at the end of October, last few weeks of October. So if you maybe want to join, already a lot of speakers from the Danish community came to our event last year, which was really nice. If you want to join, it's in Switzerland, actually, not in Italy, really close to Italy, but in Switzerland. But information will be out. You just can follow me or Power BI User Group Italy on LinkedIn. Into the presentation. The outcomes of this session. Understanding direct query, okay, for sure, because we are doing a session about direct query. Understanding the trade-offs when you want to consider using a direct query solution for your architecture in place of an import mode architecture. And being able to make the right choice, when you can use it and when you shouldn't. As I said, sometimes when you approach this kind of projects, the surface level analysis that you can find out there on direct query is pretty much, oh, well, direct query is live, but it's a little bit slower. Import mode is not live. It requires batch processing, but is faster at query time. Okay, that for sure is, I would say on average is completely true, but we want to go a little bit deeper into these considerations. And so today we will see how I was saying, we will see both the technical and also the not technical considerations that you need to make when approaching this technology. So let's start by defining direct query. Again, it's a very simple definition. You could talk for hours about just the definition of how it works, but pretty much is the storage mode of Power BI that allows you to query data directly inside of your source database. So you don't have to import the data in the VertiPaq engine of Power BI. You don't need to cache the data. You can query it directly on your source. If you have a data warehouse, if you have a data source that can be queried with direct query, you can query it directly there. So some characteristics of direct query, well, if you have a source data that is live, maybe your database contains live data and is not the result of further batch processing, you get live data in the report as well. And this is most of the time the reason why direct query project starts. Like there is a manager, someone from business, someone that read online, oh, there is direct query, data will be live, let's do direct query. This is 90% of the time how it starts. Is it needed? Is it not needed? Everyone knows that most of the time we don't need live data for most of our requirements in business, but still there are some cases when it is needed. In the model, you have the schema and the metadata. You don't have to cache the rows of the data in import, as I already said. So the key concept is that Power BI becomes a visualization layer that sends query to a source and returns, takes the result, ideally, and just displays them. So the idea is that we would like to use Power BI. Well, we write DAX, of course, DAX measures, but the heavy lifting is done by your source database. Okay, now let me see if it lets me continue. My first time using this tool for presentation. I think it's really good, but sometimes I can't use it properly. A little bit of a deep dive inside of what I said in the previous slide, which was pretty much high level. Here is an image that comes from SQLBI.com. SQL BI, great source of reference for everything related to DAX, Power BI, VertiPaq, all this kind of stuff. National pride of Italy, as you know, so we are very happy that they are from Italy. How does the VertiPaq engine work in the two modality? This is a really high, again, it's more detailed than the previous slide, but we are still at a high level explanation of things that are very deep, very technical, but we want to have an idea. So when you are in import, you build a query in Power BI, a DAX measure. The query runs against the local instance of analysis services that you have in your Power BI model, or remote instance of analysis services if you are connected to a remote model. And then the formula engine and the storage engine kind of work together to produce the result. And they divide, let's say, they assign each other different tasks. Some are related to retrieving the data cached in the import model, and that's mostly done by the storage engine. And some are related in calculating the actual output of the measure, let's say the logic of the analysis, and that is mostly done by the formula engine. It's not that the formula engine does everything related to the logic of the measure, and the storage engine just retrieves the data from the cache data. They work together most of the time to produce the result. And for this, to explain these concepts, there is a book that I don't know if my camera shows, which is the Optimizing DAX, and it's around 800 pages. So you can understand that it is not easy to explain it in one slide of PowerPoint in 2 minutes, but that's pretty much what happens. Now, the difference with direct query is that you don't have the data anymore stored inside of Power BI. So what the storage engine does, and what the formula engine and the storage engine do, they try to push the calculation down at the source level. And the formula engine ideally just needs to do very little of operations. So ideally, we want the source and the data source, the data warehouse, the database that we have as the source to provide us with exactly the amount of data that we need to display in the report. So there is much less work that is supposed to be done by the Power BI engine. Now, this is, again, a high-level idea of how it is supposed to work, but we should keep it in mind to explain a few of the trade-offs that we will need to discuss later. Because we now have a data source that is much more important than it was before, because before the data source was there, my database, my data warehouse. It is periodically refreshed as the image shows, but pretty much that's it. It just gives the data to Power BI, and Power BI does everything else. Well, the analysis services engine with VertiPaq and so on. Okay, but Power BI does everything else. In direct query, no, this is not how it works. We get data from the source, and ideally, as I said, we want to have exactly the amount of data that the user requested from the source. So it sounds great. Now, what I described sounds great on paper, because there are a few reasons why this sounds great. Well, import mode has a few pain points. For sure, no live data in import. You can go up to, I don't even know how many batch processes you can do during the day with Fabric if you have the most premium capacity available, but it's not going to be live. It's going to be batched a lot of times, but it's not going to be live. Processing a Power BI semantic model can be an error-prone activity and a slow one also, if your model is really big. So removing the need to transfer the data from your data source to the Power BI database sounds like a great thing, right? Because I don't have to process anymore. Sometimes these processes take a lot of time. Then there is an error. If you have an error, for example, let's say you have a process that lasts like 30 minutes, 1 hour for a really big model, and it errors out. And that's another hour that you need to wait to get your data, to give the data to the users. You don't have that in DirectQuery because it's querying the data directly in the source. Lighter models, well, you have the data in the source, so you need to work on the source, but your Power BI management, a little bit easier because you don't have a big copy of the data also in Power BI. And well, I wrote single source of truth. I should probably have written one copy, not single source of truth, because technically one single source of truth is another thing. But basically we are saying there is not an extra copy of your data sitting in Power BI. If you have your data in your data warehouse, you're not copying it again in another database. And this is another thing that if you work with Power BI, you know it sometimes causes errors, because if you have complex processes that process just a few partitions, that process just some, again, partitions of data because the model is too big to be processed all the time, you know that you might end up having misaligned data between the source and your Power BI model, because it's not easy to manage partition models, right? Maybe you forget one day to refresh a partition, and then the day changes, and so the partition is not refreshed anymore. You've lost your data, all this kind of stuff. But, and this is, I would say, the I don't remember the expression, but the most important lessons of this presentation, there's no magic solution with technology. This is true for DirectQuery, this is true for AI, there is true for everything. There is no magic in anything. Everything that you gain something from something, you are paying a cost in another place. That's pretty much always true. Of course, there are improvements between technologies and so on, but this is a hard truth that, in my opinion, you should always consider. And DirectQuery has two kinds of limitations, one visible and one hidden, as I said in the beginning of my presentation. The very easy, in my opinion, the easier to find all the technical ones, because you can read a list of limitations in the Microsoft documentation or SQL BI book and articles. So you will find them somehow. It's going to maybe take some time, but you will find them. The others are more subtle, in my opinion, and maybe those are the ones that, as I said, the real value that I can add with this presentation, that I found them out by experiencing them myself in a project. So let's jump into the trade-offs and let's see the list. There is a list here, but let's go over them one by one. So the first trade-off that people don't usually consider is that, well, you need a new skill set. Maybe you already have it, but it's not so obvious. It's not so obvious that you are able to work with this new technology, because before, all the calculation, everything was managed inside of Power BI. So if you know the Power BI engine, you know how VertiPaq works, you know how DAX works, you can write DAX, you can debug DAX. That's it. You can not care in most of the time. You could even not know SQL. I know that I'm saying something that people will say, how can you say that if you work in BI, of course you need to know SQL? Yes, but technically speaking, if you work in Power BI and your processes works, moves the data inside of Power BI, you can forget about your source. Maybe someone else maintains the source. It's not so weird that you have a team that maintains the data warehouse and a team that maintains the semantic model and creates the DAX and so on. Now you need the skill set to work with SQL and the database. Again, it might be not a problem for many people because there is an overlap in skills many times. The people that know Power BI and DAX and so on, they also know SQL, but it might not be the case. And you don't just need to know SQL. You also need to be able to optimize a database. Now that's a different skill, okay? That's a skill that I don't have. I know how to do some things, but I wouldn't refer to myself as a database admin or as a database developer, someone that is actually able to prepare a database to be queried by a solution like DirectQuery. And you need to do it. You need to put the indexes, you need to balance the loads of the queries, you need the ability to read the execution plan of a SQL query. No, it's not easy. You need access to the database, of course, which is not so obvious again in big organizations. And also, the sources are not all the same. I mean, if you're deciding to work with DirectQuery, which is going to be your source? Because SQL Server works differently than Databricks, works differently than a MySQL source, works differently than Snowflake. All these sources, which I think all the ones that I mentioned are supported. Now I don't remember the complete list, but they work differently. They have different optimization patterns. So it's not obvious to just say, okay, I switch to DirectQuery, and that's it. It's not always a SQL Server that you have as your data source, because SQL Server is what most people that work with Microsoft products know. So this is the first, in my opinion, trade-off. Now, the second one is you can only optimize so much, meaning even if you know how to optimize a database, like you have a SQL Server source and you are a SQL Server expert, you know how to optimize it. But in a BI scenario, this is not so easy because it's not as easy to predict how the data warehouse will be used by your business users, maybe that are building on top, that are building, Power BI reports in DirectQuery, because they will write new DAX measures every day, for example. You can't predict, you can't build indexes that are going to be on the database, on the source database, that are going to be correct for every possible situation. It's very difficult to predict. This is in contrast with, for example, if you develop a software on top of a database, if you develop an application, you have control over which store procedures and functions are run when the users do something in the front end. You just give the users a front end and a set of predefined features and things that they can do. And in this way, you are able to optimize your database in the correct way. But in BI, this is different. This is different because the users need to have the possibility to create new measures and to create new DAX queries on top of the data. And that means that optimizing in advance is really not easy. Now, these were two not technical limitations, as I mentioned. Well, they are sort of technical, but they are not like an hard technical limitation. They are more organizational problems. And now let's analyze a little bit actual technical limitations. One of them is the way that DAX is translated to SQL. There are some functions, some situations in which DAX cannot be converted to SQL in an easy way, in a straightforward way, how you would expect it to convert. The issue with this is that if you have a large materialization, meaning a large set of data coming from your source, two issues. One, the queries will be very slow. Second, the query might actually error out because you have a 1 million rows limit when querying a source in DirectQuery. You can change this parameter, the 1 million rows, but that doesn't change anything. I mean, the number that you can put whatever number, but it's going to be slower and slower and slower. So the 1 million rows actually makes sense because if you hit that number, probably your query is already too slow to be used anyway. Let's say you put 5 million, okay, it's going to be really slow, and you might even hit the 5 million rows if you have a big data set. Again, as I said, this might be caused by unsupported functions that do not translate directly in SQL, functions that you would expect they operate in a way, but they operate in another way, and also unexpected behavior from page, visual, or report level filters. This is actually something that I found out myself while testing, because most of the other things you can find in books, you can find in articles. This is actually something that I found out myself. So let's go over how this works. Sometimes it works as expected. So if you execute a measure that, for example, is just a count rows grouped by year and month and with a filter for 2 years, 2024 and 2025. This works perfectly on most sources. I would say all sources. I haven't tested on all, but most sources. It's a select. I mean, it generates kind of weird SQL, and I even simplified it here. But it's a select of month and year, and then it counts the number of rows, and then it groups by month and year. And it returns the result to Power BI. So this is the perfect scenario. Very simple measure. It returned what? 24 rows of the data, 24, because 12 months in a year, and you have 2 years filtered in the query. So that's a perfect scenario, right? But that doesn't always work for every possible DAX function. One of those is the time intelligence functions. Most time intelligence functions require the source engine to return data at the daily level. It's not possible to translate a function like same period last year directly to a SQL query and return the aggregated result. That's the way that Power BI and the source work. So basically what happens is the data is returned and the daily granularity. Now you can understand why this is a problem. In a year, we have 365 days. So all of your queries, even if they are grouped by year, they will be multiplied by 365 potentially. It may remove the rows that have no data for certain days, but let's assume you need to do a plus 365 plus the numbers multiplied by the numbers of years. Sorry, with the getting a little bit confused with the English here. So again, there are functions like the time intelligence functions that need to retrieve these big data sets to be able to compute the actual calculation. And I explained it here, I mean, in a bit of a simplified way. Storage engine cannot translate the full time intelligence logic. So it just says, okay, give me the data, the formula engine will do the rest. When this happens, regardless if it's time intelligence or something else, you have a problem because you have a user asking for a certain amount of data, like the user expects maybe data aggregated at the month, but it gets back actually what he's asking to the engine, not what he's asking, but what he's receiving from the source engine is much more data. So the queries might error out, the user doesn't know why, bad experience, he blames you because you are the, I don't know, model developer. This is an example, again, time intelligence measures. The core problem is the daily granularity that is needed from the source, regardless of how you aggregate it. And then you have your 1 million rows hard limit. But again, it's not just about the hard limit of the 1 million rows, because if you hit that limit, you'll very likely have a very slow report already. So you don't want to end up in this kind of situation. And I made an example here, and I hope that my mathematics isn't off, but you might reach this not with a very big model, because sometimes people think, oh, but the problem will only happen if you have big dimensions, right? Because what we think is, okay, the fact is aggregated. It's a count row, it's a sum, it's an aggregation. So the fact can even be millions and millions of rows, I don't care. And if I have small dimensions, this problem will not show up, right? Because, you know, I have a few products, I have a few years, I have a few customers. Even if I combine them all, I don't reach 1 million. Like the product of all these dimensions is not going to be over 1 million. Well, it is true, but there are situations in which the user might try to do something that is not so weird, and still the request to the source engine exceeds the 1 million rows. Like, for example, a matrix showing year-over-year percentage growth or whatever calculation that you want to show that uses a time intelligence function for 80 customers over 40 years of data. Maybe you're a company with a very big database. Now, all of this needs to be multiplied by 365 days for every year. It's not an impossible matrix that the user might decide to build. Like I've worked with, sometimes maybe it doesn't happen with business data because we don't go so back. But if you work like with institutions that do statistics, they might go as back as 40, 50, 60 years of data. This has happened to me with the customers. It wasn't direct query, it wasn't this situation, but it might happen that they want to see how, for example, the trend of GDP grows over a lot of years. So there are situations in which you can cause this 1 million rows hard limit without realizing, with a very small front-end matrix, which is actually asking a lot of data. And then there are other situations, like, for example, the divide versus the if optimization pattern. This is very well explained in the Optimizing DAX book. I decided to mention it here as well. There are some, because the lesson in this point is that there are patterns which work really well in import mode, but in direct query, they would work exactly in the opposite way. And that's the divide versus if, for example. If you are in import, we all know that divide is very efficient in handling the division. And using if might produce slower queries. Not always true, but that's a rule of thumb. With direct query, if is managed much better because the SQL engine can manage an if much better than the VertiPaq engine can. So you get two patterns, and let's assume that you are doing, for example, a migration. You had an import mode, and you want to switch to DirectQuery for the future. Well, prepare to rewrite a lot of DAX code. That was true for the time intelligence, because you need to rewrite time intelligence pretty much from scratch using different techniques to write time intelligence. Or I suppose you could use the calendar-based new tool that was provided. I haven't explored that yet, but they told me it solves some problem. And that's another case. The divide versus if is another thing that you might need to change in your setup, in your measures. Another example that, as I said before, I found out myself when testing on for my customer is the way that report page and visual filters work. Now, in our situation, we had this. We had a Power BI import mode, a semantic model in import analysis services in import mode, and we have some reports that were managed by us. So we know that being Power BI developers, being business intelligence people, we know that you shouldn't use conditions such as contains or not contains as a page level or a report level or a visual level filter in Power BI. Why? Because usually that kind of filter slows down your queries, even in import. Even in import, it slows down your queries. So when you have this kind of situations, you try to push the transformation, the filtering as back to the source as you can, and you try to avoid using it in the report layer. But we also have an entire company that has business users that are doing this kind of stuff. Because for a business user, it is completely normal to use a filter like is not, contains, does not contain on the Power BI report. It doesn't know the fact that probably it's not optimized, probably it's not going to work well because doing a contain over a text field is not easy, for any engine in general. So they were doing it. And I mean, it's completely normal. It's not weird. It's completely normal that they would do that because Power BI allows them to do that. Now, in some cases, and it's really difficult to predict and to find out, but in some cases, these kind of filters cannot be pushed down to the source engine. There are situations in which the same filter, like the contains or does not contain, is pushed. So it is read by the SQL engine and just the right amount of data is returned to Power BI. But there are also situations, this is especially true in columns with a high cardinality, high number of unique values, where a certain type of does not contain or contains, it cannot be translated. So the engine just says, okay, give me the entire set of data. The formula engine will filter what you send me, will apply the actual filter. And what does it mean? Not only that the query is lower, but in this situation, you might actually hit the 1 million rows limit very easily because you have a filter, you have a user that is putting a filter, he expects to retrieve few rows of data maybe. Actually, the query needs to ask for the entire dataset because the filter has not been passed. So, and it's hard to debug. It's quite hard to find out when this is going to happen because it's not like if you have more than 5 unique values or more than 1 million, more than 500,000 unique values is going to happen or not. It's quite hard to find out when this is actually going to happen. Now we have another set of technical limitations, and those are the features that you will not be able to use or not be able to use in the same way as you were doing in import. And those are Power Query, calculated columns, and calculated tables. Power Query, you can still use it, but if you break it is technically possible, but each transformation needs to run every time, right? Because Power Query in import, it runs with the batch processing. So 1 time, 2 times, 3 times, 4 times a day. Power Query in DirectQuery needs to run every time. If you add an additional transformation, it needs to run with every query. Now, of course, if you are in DirectQuery, we know we move the transformation to the source DB. This is something that we need to do most of the time anyway. We don't want to use DirectQuery if we don't have to, because it introduces an additional layer of transformations directly inside of the semantic model that you most likely don't need. Just prepare a view in the database and have it filtered beforehand. But again, it's a limitation that you need to consider. And calculated columns are not as powerful a feature as in import. I don't want to go into the detail for this, but they behave differently. And why do that? Well, to put it extremely simply, why do you use calculated columns in import? You use them because you pre-aggregate something, you pre-calculate something in the imported model. So you prepare the calculated column, it is evaluated at refresh time, at process times, just like the Power Query transformations, and then you have it there stored in the model. So you use them to pre-calculate something that you will use, but now you don't have data in the model. You don't have nothing stored. So it needs to be calculated every time as well. And then calculated tables, not supported. You need to have a local model for that, not supporting a pure direct query model. Now, another trade-off that is not so easy to think about beforehand. As I said, my goal is to share also stuff that you don't find in documentation that maybe you don't think about. If you have a self-service BI scenario, how would that impact in direct query? Well, it would have pretty big impacts. Because as I said before, first of all, what is a self-service BI scenario, in case it's not clear? It's not clear to me as well, because there are different definitions for it, but let's use one. It's a scenario where you build a centralized model, you share it with the company, you share it with other users, and then you have people like report creators and business user, or if you like to call them power users, sometimes they are called, that build on top of the shared semantic model that you built. So there is a model, you give it out to the company, go ahead, build local DAX measure, build local things in your thin report connected in direct query, and yeah, have fun, build whatever you want. Now, in import mode, you can have users write bad DAX and it will still work. I know that this is not something that I am supposed to say, being Italian and being that Mark and Alberto write about good DAX all the time. So that's probably a little bit insulting, but it happens. I mean, I've seen extremely bad DAX in the models that I've analyzed over the years, and it still works. Maybe it is a little bit slow, but it works, okay? Import mode is extremely powerful. It surprises me, like the amount of stuff that does iteration, some axes with calculate, stuff that isn't supposed to be done in that way, but it still works in a decent way. Now, in direct query, that's not the case at all. If you have business users, power users that do not know that they are not DAX experts, which is not so rare because DAX is not easy to learn and it is non-transferable. It's a skill that you just use it in Power BI and analysis services. So it's not so rare to find people that don't know how to write DAX, even in technicians' environments. Now, in direct query, that will not work. If you have bad DAX run on direct query, it will be extremely slow. It's not even about, as I said, the 1 million rows limitation to ask to the source engine. It's just not going to work. It's going to be so slow. The experience is going to be terrible. So again, real world consequence, imagine going to your business users. If you are in a big company, there might be 100, 200, 300 people, and you tell them, oh, you know what? All those measures that you were using, they are not going to work anymore, or they are going to take 10 seconds to run every time you use them. It's not easy. And when this happened to me in my personal project, and I asked around a few questions, how should we do this? How should we do that? And people were saying, oh, we can train the users. Okay, it's not easy. I mean, you don't just magically turn 100 people that do another job and just want to use Power BI as an analysis layer into DAX developers. Okay, because to write DAX for direct query, you need to be a DAX developer. You need to understand how the engine works. You need to understand how to write time intelligence without using the time intelligence syntax sugars. So there are impacts in this sense. And as I said, this is not a technical challenge. It's an organizational and change management challenge that is really easy to underestimate. To just say, okay, we will train people. Oh, we will rewrite the DAX. It's not that easy. Now, of course, there is room to optimize direct query. There are a lot of things that you can do to improve on how direct query works. The biggest one, I would say that the best situation in which you can be to work with direct query is to have full control over the model and over the DAX that is created. If you're working on a project where you as a developer have control of your semantic model, you can build the DAX and you just give it to the user and you say, use the measures that I built. Don't build other measures. Or if you do, Just keep it extremely simple. Okay, DirectQuery is a really good solution for a lot of reasons that we discussed in the beginning of this presentation. Live data, if you have live data, no processing, all this stuff. As soon as you start to have situations in which the users need to write their own DAX, it's complex. Now, room to optimize. Well, star schema design, to mention one on this page, of course, the star schema is always the best design pattern, data modeling pattern for Power BI, whether it's in import or in DirectQuery. When you go to that, again, similar to the example I was making before, when you work in import, you don't have to do star schema all the time. Again, I've said another things that is going to damage my reputation, but come on, you don't have to do it all the time. You can take shortcuts. You can create sometimes bidirectional relationship. You don't have to strictly adhere to the star schema, because import mode, again, really powerful. It manages the query really well. In DirectQuery, that is not the case. The same as the DAX, you need to have a very good model and to avoid stuff that is going to be difficult to be translated for the SQL engine. Query reduction is another thing that I learned that I didn't even know it existed. But you have basically buttons in Power BI and that you can set up to avoid launching a query every time you click on a slicer. I honestly, I did before doing this DirectQuery, how do you call it? This DirectQuery session experience with DirectQuery, I knew that there were an apply buttons in the slicers, apply slicers in the options. I didn't know what it was. Like one day they just introduced it. I didn't know what I should do it, but it actually is really useful in this situation because you can avoid launching a lot of queries each time you change a filter and just launch them all at the same time. Query folding with them. If you use Power Query, you need to try to fold the transformations as much as you can to the source engine. And then you have aggregation tables and dual storage mode. There is a question about this from Anand. On aggregation tables, wouldn't having more tables add more relationship, which in turn slows down querying in DirectQuery? Okay, this is a technical question that is not easy to answer now, but basically it would enable you to switch between a DirectQuery query on the entire data set and go on a pre-aggregated version of the table that you have in import mode, for example. The way that it works in Power BI is it doesn't add more relationships. It just falls back to the aggregated table when it can. Or to better put it, it tries to use the aggregated table. When it can't, it falls back to the non-aggregated table and does the calculation from start. But again, both the aggregation tables and dual storage mode would require a lot of time to be discussed right now. But useful features in this situation. Another thing that you can do that might be useful, I forgot to put it in the slide. You can activate flag, enable referential integrity. I don't even know what it's called anymore, but basically it assumes that there is referential integrities between the facts and the dimensions, and it always uses an inner join when doing the queries. So it will help a lot in, well, not all the time, but it will help in avoiding left joins, which can be a little bit slower sometimes. I know that I'm not giving out precise answers, but everything needs to be tested with the specific situation that you are analyzing, like everything with Power BI. So when should you use DirectQuery to close the session? Is DirectQuery bad? Because I made an entire presentation and I pretty much just said, oh, there is this limitation and there is this other limitation and so on. But of course, there are situations in which it's really useful. If you have data that changes a lot, like you want to set up a monitoring dashboard for alerting, okay, you don't have a lot of other options. DirectQuery on a database that is live, of course, it's not the result of other processing, and DirectQuery as a connection mode. In this way, you have live data. Data volume cannot fit anymore as an import in a Power BI semantic model or in analysis services. If it costs too much and so on, if you can't, okay, you can switch DirectQuery. Or you have stuff like GDPR and so on, where you can't move data around. Import when everything else. All I've explained right now are all reasons to go for import. So I will not dive again into it. Import mode is the default for most scenarios. We already know this. Probably you already knew before coming into this session that import is better than DirectQuery most of the time. Probably now you know a little bit better why it is. And not just from a technical point of view, but also from the requirements in changing the way that you work. Okay. What else what else they want to add? Again, very important. If you have control over your semantic model and your DAX measures and your source database, and you can optimize it in the correct way, then direct query might be a good solution. Otherwise, import much better. Direct Lake, I don't know. I just wanted to mention it because I know that there is Direct Lake right now as well. I know a little bit what it does. It is supposed to basically give you the performance of import, but in a setup that is similar to Direct Query, meaning you are not actually importing data inside of your semantic model. Now, my point again, I follow the principle that I explained before. There is no free lunch in technology. So when they tell me the Direct Lake gives me import-like performance with the Direct Query feature of not having the data imported, I am a little bit skeptical. And I really want to test this out before I talk about it in a session. Now, first of all, Direct Lake is just in Fabric. So you need to be on Fabric you need to be on Microsoft to do that. That is not the same with the Direct Query. Direct Query can query also other kind of databases of other vendors and so on. So already being tied to Fabric is one cons of this solution. But then I also would like to really test if it's true that the Direct Lake provides the same performance of import, because some friends that have tested it, they told me it's not like that. So I will see. Maybe there is room for another session in the future. Rule of thumb, I've already said it 100 times. Import mode is the right default for most scenarios. But if you have a specific scenario, go for Direct Query. Now you know what could be the problems of using Direct Query. And that's it. That's pretty much it. So if you like this presentation, if you want to give a feedback, that will be really useful. Especially, or actually, if I can, I will write the link in the chat, because I hate it when they force me to use a QR code. So I will try to find my my link to my survey, and I will share it with you also here in the chat. But if you can give me a feedback, especially on what you liked, but what you didn't like, you wanted to see more stuff, less stuff. I got feedback in some other cases, like when I was at Tallinn, that I tried to put too much stuff in my presentation, which was a completely fair feedback, and it was really useful. So I tried to keep it a little bit lighter, and as you saw, I skipped on some things like aggregated tables and composite models and so on. That would make it even more difficult to discuss this scenario. So I'm stopping the sharing. I hope that you used the QR code. If you didn't, again, I will try to share the link.
All right. I guess there's one last question from Marco. Is there a way to understand how a DAX query is interpreted into SQL to know if it can be optimized and how?
Yeah, Marco. Of course. There is. Sorry, Jens, I'm meeting echo. Thank you. Marco, of course, there is the possibility to know. You need to be able to read the queries that are launched by Power BI on your source engine. So if you are in Fabric, for example, you can use the monitoring tool of Fabric, like I don't remember the name, but Fabric keeps a trace of the queries that have been sent on your warehouse, for example. There is literally an option in the menu of your data warehouse in Fabric that allows you to see which queries have been launched on the warehouse. And those are the queries that are coming from Power BI, and they will be SQL. Another way that you can do is you can use SQL Server Profiler if you're using SQL Server, or in Databricks also. We use Databricks for Direct Query. There is a monitoring session where you can see all the queries that are launched from Power BI to Databricks. Pretty much all the vendors provide you with a monitoring tool that has the log of the queries that you launched against your data source. And it's not different when you are working with Power BI. It's not different than if you are launching a query from the database, like from SQL Server Management Studio. Like it will be recorded in the same way, and it will probably say that it was launched from Power BI. At least Databricks provides that. I don't know if Fabric does. Is interpreted well. You basically need to have the, like I was saying in my session, you need to have the skills to read the SQL query and see what is missing from the request that you sent from Power BI. Another thing that you can use is the in Power BI you have the monitoring tool, like the one that I don't remember the name, but It gives you the timings for each visual, how much it takes to render the query that was launched. And you can copy, the performance analyzer, right? You can copy the query from there, and it will tell you the DAX query and the SQL query as well. At least if you are querying a Fabric warehouse, that's where I tested it. It tells you directly from Power BI, there is you copy, you paste it in, I don't know, Notepad or something. There is a piece that tells you this is the DAX query, and there is a piece that tells you this is the SQL query. So that way you can put it all together and see, if that's the result that you wanted or not. I'm just going to share the form because I said I was gonna share it. Let me, how do you do it? Got it. Collect responses, copy link, that's it. Okay, as I was saying, sorry, Marco, I hope that answered your question. And as I was saying, if you want to give me a feedback, that would be really, really appreciated. And also connect on LinkedIn, by the way. If you find me on LinkedIn, you want to ask questions, feel free, absolutely.
All right, I think that concludes the session. Thank you very much for a great walkthrough of DirectQuery. And perhaps I should interest myself in getting a session on Direct Lake as a follow-up for this. But thank you very much for your time, and I think it was a very interesting talk. Some great feedback in the chat, and I hope also that will be the case in your form. Remember to share it with the participants. So thank you very much. Thank you everyone for joining, and see you in April.
Thank you. Bye, everyone.
Bye-bye.